5.5 part 2 is on roots of real numbers. Okay, so now, like I said, we're going to talk about cube roots, fourth roots, and so on. Okay, so it says we know that squaring and taking the square root are opposite each other. So like multiplication and division are opposite each other. Addition and subtraction are opposite of each other. They're inverses. So they undo each other. So when I have 5 and negative 5, those are square roots of 25 because 5 squared is equal to 25 and negative 5 squared is equal to 25. 2 is called the cube root of 8 because 2 cubed is equal to 8. 2 and negative 2 are called the fourth roots of 16 because 2 to the fourth is equal to 16 and negative 2 to the fourth is also equal to 16. And a is the nth root of b, so I just said a is the nth root of b if a to the n is equal to b. Okay, the nth root of a real number, so we'll say a real number a, is written like this, the nth root of a. And there's lots of fancy words for these. So n is called the index, and a is called the radicand. I don't care if you learn what the word index and radicand is. I will usually call it what type of root are you taking and what is under the root. So index and radicand. When a number has more than one real root, the radical sign indicates only the principal root. So this is something that math teachers across America get wrong every single day. And it drives me crazy. We're not going to get it wrong. Okay, so there's two types of problems. The first one is when there's square roots that are already in your problem. So let's say I have the square root of 16 plus the square root of 81 minus x equals 2x. So that's the first type of problem. The second type of the problem is when you actually have to take the square root. So let's say I have that. 2x squared equals 32. Okay, if the square root is already there, there is an imaginary sign in front of the square root. That sign is a positive sign. It's like there was positive square root of 16 and positive square root of 81. There was no negative sign, just the positive number. This is called the principal root. So the sign is already there. So the square root of 16 is just 4. The square root of 81 is just 9. Then I have minus x equals 2x. And I solve it just like normal. So I get 13 equals 3x. I add the x over. So 13 over 3 equals x. There is no plus or minus. This is my one answer. Right? I didn't do plus or minus 4 and plus or minus 9. It was just 4 and 9. That's what I'm talking about with the principal root. So if the root is already in your problem, it's already positive. Unless there was a minus sign in front of it, then it's negative. All right, the other type of problem is like this. So if I have 2x squared equals 32, I would first divide by 2, and I get x squared is equal to 16. Okay, but I want to solve for x. Do you guys agree that there's two solutions? Right, 4 squared gives me 16, and negative 4 times negative 4 gives me 16. Do you guys see it? Two answers. So when I take a square root, so whenever I'm the one taking the square root, I write plus or minus every single time. That gives me a solution, x equals plus or minus 4. So I did not do a plus or minus here, like where I did the square root of 16 originally, but I did do it here. Do you see the difference in the two problems? In the first one, the square root was already there. In the second one, we took the square root. If you are the one taking the square root, you always write plus or minus. My AP Calc students still forget the plus or minus. You need the plus or minus. There's two solutions. Does this make sense? Okay, so that's what a principal root is. All right, so that's why I said in here, you take a odd root, an even root, whatever. Okay, so let's say I have an example, like x cubed equals 27. Okay, if I'm taking a cube root, I only have one answer. My answer here would be x equals 3. So I have one answer. Same if it was a negative, right? If I had x cubed equals negative 8, there's a solution. I can take the cube root of negative 8. What do you guys get when you do the cube root of negative 8? 2. Negative 2, right? So x equals negative 2. There's one answer. I did not do a plus or minus. That was the one answer. The next type is if you have an even root and a positive number under the root. So let's say I had x squared equals 16. When I take the square root, I have to write a plus or minus. Okay, that means I get two answers. I get x equals plus or minus 4. So there's two solutions. But if I had x squared equals, let's say, negative 81, when I take the square root, you can write plus or minus, but you have the square root of negative 81. You're not going to have like negative 9 times negative 9 gives you a positive, or gives you a negative 81, right? It's going to be a positive 81. This is no solution, no real solution. Have you guys ever heard of imaginary numbers? We're going to get there, yeah. So that will be very soon. We'll talk about imaginary answers. But right now we have no solution, right? No real answer. All right, well, what if we have a 0? So what if I had x squared equals 0 and I had x cubed equals 0? When I take the square root, and then when I take the cube root on the other one, right, I just get one solution. I get x equals 0. So there's just one answer there. The answer is 0. So if you have a square root of a negative number, you're going to have no answers. If you have the square root of a positive number, you're going to have two answers. Cube root, fifth root, whatever, you're going to have one answer. All right, so fifth roots of 32. Are you guys at the point where you know the fifth root of 32? 2. You could always do your factor tree if you need to. Cube root of negative 125. Does it work? Yeah, it works. What multiplied by itself 3 times gives you negative 125? Negative 5, right? All right, eighth roots of negative 256. No solution, doesn't work. No real solution. I'll say real for now. No real solution. All right, this next one, there's a plus or minus, so it's going to be plus or minus 4x cubed. Do you guys see why it's x cubed? Imagine you have 6 x's lined up. How many sets of 2 do you have? 1, 2, 3 sets of 2 of them. All right, same idea here. If I had 4 of these q cubed plus 5s, so I wrote them 4 times. When I take the square root, I'm looking for pairs. I have 1 pair, I have 2 pairs. So this is negative, parentheses, q cubed plus 5 squared. I should never do q cubed. It's just mean. It's like a tongue twister in math. All right, next one. So the thing that throws people off on this next one is the 24. Well, think about 24. 24 breaks into 4 and 6, which is 2 times 2 times 2 times 3. So if you have the fifth root of that, there's no like set of 5 items, right? Okay, so we leave it. It stays inside the root. So the fifth root of 24 stays how it is. It's still the fifth root of 24. I'll put it off to the right side. But what about the A's and the B's? So if I have 10 A's all lined up, how many sets of 5 do I have? 2. It's just division. That's all we're doing. We're saying we have 10 items, divide into groups of 5. So it's A squared. And then same with the B, B cubed. And then D, the square root of negative 4. No real solution, or no solution, right? All right. So you love when your math teacher says this. Now on to the most confusing part of this chapter, so pay attention. Gotta love that. All right, I'm going to take a little survey here. If I have the square root of negative 5 squared, there's usually 2 answers that people give me. So some people think it's 5, some people think it's negative 5. So how many of you guys think it's 5? Raise your hand. Okay, I see. Emerson raises his hand, so you're like, yeah, I'll raise my hand too. How many of you guys think it's negative 5? Yeah, so some of you guys think it just cancels. It is 5. I'm so mean. It's 5. It's confusing, isn't it? It's like, wait, shouldn't the square root and the square just cancel each other out? You would think. They don't actually. Now, if I had the square root of 8 squared, then they do. It's just 8, right? But in this case, it is 5, because here's what's happening when you do that problem. What you're saying is the square root of, it's kind of like order of operations, start in the middle. Negative 5 times itself gives you 25. The square root of 25 is 5, right? The principal root, the positive. All right, so if it's a positive already, you're going to get a positive in the end. But if it was negative, you're going to get a positive. Yeah, Allison, you have a question?
What if it's like negative 5 cubed?
If it was negative 5 cubed and under a cube root, then they would cancel. They'd just be negative 5. Because this would be cube root of negative 125, which is negative 5. Okay, so there's something weird going on with even roots in particular. Square roots, fourth roots, sixth roots. Okay, so what do we think? If I have the square root of x squared, is it just x? It is not. If x was negative, it will now turn to a positive number, just like we said over here, right? If x was negative 5, it becomes 5. So it's not x. What is it? Not plus or minus either, because it's not 2, it's just one answer. Absolute value. It always becomes the positive version of what it was. Does it make sense? So if I have like negative 7 squared under a square root, it becomes the square root of 49. The square root of 49 is 7. So you take the number that's here, and you just take the absolute value of it. But if it had been like a 6, 6 squared is 36 under a square root, so you get 6. That one stayed the same, right? So it's always the absolute value. Okay, question. What if I have the square root of y to the 4th? What's that? Y to the 2nd. Do I need a square root? Or do I need a, not square root, an absolute value? I don't. Why do I not need an absolute value here, but I did here? Yeah, Alex? Yeah, anything squared is positive anyway, right? Positive anyway. It's kind of redundant, right? We don't put like if I had 5, I'm not going to write square root of 5, right? It's just 5. I don't need a, or not, why do I keep saying square root? Absolute value. If I just have 5, I'm not going to write absolute value of 5. I'm just going to keep it as 5. Same thing with x squared or y squared. That's already positive. I don't need absolute values around it. It's going too far, right? It's already positive. So you have to think about that. So here it says, if you're trying to find the nth root of an even power, and the result is the number raised to an odd power, like 1, like x to the 1st, x to the 3rd, you must write the absolute value of the result to ensure it's non-negative. And then it says here, you only need absolute values around variables. It wouldn't make sense to write absolute value of 5 instead of 5. That's what I was talking about. Okay, so here's your key. If it was an even root, and you ended up with something to an odd power, use absolute values. That's the big thing. You start with an even root and you have something in the end that's raised to an odd power. You need absolute values around it. Okay, so what I always tell people is to go with their intuition. Like, write what you think it is without any absolute values, and then at the end of your test, just go in and put the absolute values where they're needed. Just say, even root, odd power, yes. Okay, so in this one, if I have the 8th root of x to the 8th, it's just x. That's what I would think, right? I'd be like, oh, it's just one set, right? It's just x to the 1st. Okay, but at the end of the test, you would go through and you'd say, does it have an even root? Is it raised to an odd power? And yes, it has an even root. It was it was the 8th root, right? And it's an odd power in the end. It was x to the 1. So that means that we have to put absolute values around it. So it's the absolute value of x. All right, so this next one, 4th root of 81. 3, right? 9 times 9, 3 times 3, times 3 times 3. All right, 4th root of a plus 1 to the 12th. A plus 1 to the 3. Did you have an even root at the beginning? Yeah, it was the 4th root. Did you end up with something raised to the odd power? Yeah. Yes. So you put absolute values around the thing that was raised to the 3. This next one, t to the 18th under a 6th root. T cubed. Was it an even root originally? Yes. Is it now raised to an odd power? Yes. Absolute values. Basically, if t had been a negative number, in the end, t cubed is negative. We don't want negatives out. If I take a square root, I will always want a positive number at the end. All right, this one, 2a minus 1 to the 2. Absolute values? No. Why, Emerson?
Because it was an even power.
Right, you took an even root, but you ended up with something to an even power, which is already positive. Does that make sense? Like 2a minus 1, it doesn't matter what a is. A could be like -5. If I plug in -5, I'm going to get -11 squared, which is 121. It's positive anyway. Do you guys see what I'm saying? So it doesn't matter. In the end, you square it, so it's positive. All right, so this next one, 4th root of a to the 8th, a squared. 4th root of b to the 12th, b cubed. 4th root of c to the 16th, c to the 4th. You had an even root at the beginning. Did you have anything to a non-power? Yeah, so you put absolute values around the b cubed. Just the b cubed. All right, this next one. So I'm going to have 3, right, cube root of 27, x minus 5 to the 3. Absolute values? Why? It wasn't an even root, right? Is it okay to be negative if you have a cube root? Yeah, if I have the cube root of -125, it's okay that it's negative in the end. Started with odd root. No absolute values needed. Does that make sense? So you're always saying even root, yes. Odd power, yes. That's when you do absolute values. All right, this is the type I usually put on your test, where there's some that don't leave the root, so it's a little tricky. So see if you can do these ones. So 4th root of x to the 8th. How many sets of 4 would you have? You would have 2, x squared. Y to the 16th, if I have the 4th root of that, it's y to the 4. And then z to the, if I have 10 z's lined up, second, how many are left inside? 2. Does that make sense? Z squared. So if I had 10 z's lined up and I wanted to find the groups of 4, there would be 2 groups of 4. That would be 8 of them. Then there'd be 2 left over, so the 2 stay inside. Okay, same idea on number 8. This is as hard as I get. So I have the square root of 8. Well, 8 breaks into 2 times 2 times 2. So the square root of 8 gives me 2 root 2. So I'm going to have a 2, and then on the inside I'm going to have a 2. What about the x to the 5th? How many pairs do I have? 2 pairs, x squared. 1 left on the inside. Y to the 6th, I'm going to have y cubed on the outside. And then z to the 10th, I'm going to have z to the 5th on the outside. Do I need absolute values around anything? The y cubed and the z to the 5th. So I would just put absolute values around both of those like that. So it's like 2x squared, y cubed, z to the 5th, and then square root of 2x like that. That's a hard one. It's as hard as I get. You guys think you can do it? Eventually. Okay, equation. Solve the equation. So I'm going to add 10 to both sides. So I'm going to have 2x squared equals 50. I'm going to divide by 2, so I get x squared equals 25. And then I told you that whenever you take a square root, so any kind of even root, you always have to write a plus or minus. So you end up getting x equals plus or minus 5. That's your answer. Okay, let's relate this to what we've been doing. At this point, x squared equals 25, right? At this point, the second step, x squared equals 25. If I take the square root of both sides, the square root of x squared, we just said that that was something, not just x. It doesn't just cancel out, right? What did I say the square root of x squared was? Not just x, but the... You guys are almost at break time. Come on, finish these problems and I'll let you go. The square root of x squared is what? Not just x, guys. Absolute value of x, right? That's what's happening. The square root of 25 is 5. This goes all the way back to chapter 1. When you have the absolute value of x equals 5, we used plus or minus, right? So we'd have x equals plus or minus 5. That's what's happening when your math teacher just tells you to always write a plus or minus. Yes, it's kind of like they're canceling out, but that plus or minus came to the other side, right? So it was really the absolute value of x. That's what's happening. Do you understand that process? So this next one, if I have 7y cubed, I'm going to add the 7 over. I'm going to get 189. I divide by 7, so I have y cubed equals 27. I now take the cube root of both sides. I get y is equal to the cube root of 27, which is 3. That is only 3. It's not plus or minus because it was an odd root, right? Okay, try 3 and 4. See what you get. So on this one, I think most of you guys had the answer. Just be really careful, like when subtracting and all of that. So you should get 5x to the 4th equals 80. Divide by 5, so x to the 4th equals 16. And then I saw a lot of plus or minus 4s, so you have to be really careful. You're doing the 4th root this time. But it's an even root, so we still need the plus or minus. So I get x equals plus or minus absolute value, I'm sorry, plus or minus 2. I was thinking absolute values, I wasn't writing it. So a lot of you are still confused about the absolute value concept. What's happening here is when you do the 4th root of x to the 4th, that's giving you absolute value of x equals the 4th root of 16, which is 2. That's why you do the plus or minus thing, okay? Because if absolute value of x is equal to 2, then x could be 2 or negative 2. All right, so this next one, a lot of you had trouble with negatives. So you should have negative 1460, and you're going to add 2 to the other side. So you're going to get negative 1458. Divide by negative 2. And you get 729 equals z to the 6th. Okay, but then a lot of you guys didn't want to do the factor tree. You were feeling lazy, so you busted out your calculator, but you had no idea what to do with your calculator. You're like, how do I put in a 6th root? Do you know how to do it? So you just like try 2 to the 6th, 3 to the 6th. Guess and check method. What if it wasn't nice and even? Yeah, Emerson, what did you do?
You do like whatever it is, and you do like the math button.
Yep, so you can put in 6, and then you can hit the math button, and you can arrow down to choice number 5, I think it is, which looks like x root, like that. And then you can put in 729. So you can do it that way, but there's actually an easier way, which we're going to talk about in a later section. I think it's like 5.8, which is you can raise both sides to the 1/6. You're like, what? Why would we do that? The 1/6 power is the same as the 6th root. Think about it. 6 to the 1/6, like that. It becomes z to the 1, right? They cancel each other out. Could you multiply them? Gone. So a 1/6 power is the same as the 6th root. So if you just do 729 raised to the, and then do parentheses 1/6, you will get the correct answer. I guess you still need plus or minus, I should say. So plus or minus 3. Okay, so that's going to be handy on the bottom part of your homework. So I just passed out your homework so you guys can see. So what if you have like the 5th root of 241? That doesn't come out evenly. Like I don't know what the 5th root of 241 is. Okay, but if I wanted the decimal version of the answer, I would put in 241 raised to the 1/5. And I would get the decimal version of the answer. So at the very bottom of your homework, it asks for the decimal approximation using your calculator. So that's what you're doing. Basil, are you with me? I like how Jason put his hand in front of your face to see if you're paying attention. Just eating that dum-dum, just having a good old time. All right, next one. So what if I have something like this? So x squared minus 5x equals 6. Okay, these are ones where you can't like just like take the square root of both sides. Do you guys see how these are different? You have an x as well. So you're going to subtract the 6 over and set it equal to 0. You did these in algebra 1. You now factor. So you have x minus 6 and x plus 1. Try to pretend I didn't see the massive eye rolling. And then you end up setting both of them equal to 0, remember? Because it's like something times something else equals 0, so one of them could be 0, right? So you get x equals 6 and you get x equals negative 1. Both of those are your solutions. So if you have an x squared and an x, you can't just like take the square root, right? You have to get everything on one side and factor. So 2x squared minus 5x minus 3 equals 0. I was telling a couple people yesterday that these two are my favorite problems to put on tests because I'm really lazy as a math teacher and I don't like to like as you've seen before. Sometimes I don't like to put a key, like make the key before I print all 75 copies. And I know that any version of the 5 and 6s here, all of these factor. These are all good to know for your test. They all factor. Obviously not the same factoring, right? But, and same thing with the 2, 5, and 3 with this next one. They all factor. Doesn't matter with the signs. All right, so anyway, so I have 2x and x. And I'm going to put the 3 and the 1. So the 3 is with the x, the 1 is with the 2x. I need them to be opposite signs so that they multiply to be -3. And then my outer and inner need to combine to be -5. So I need a negative and a positive. So that way I have -6x and positive 1x combines to be -5x. All right, so I factored it. I have it set equal to 0. So I'm going to say 2x plus 1 could equal 0, or x minus 3 could equal 0. So x equals 3 is one answer. The other answer, I subtract 1 and I divide by 2, so I get -1/2. So 1. So -1/2 and 3 are the answers. Okay, so what if we have square roots already in them? We talked about this before. It's automatically the principal root. So whatever sign's in front of it is the sign that you have. So I have square root of 9, which is just 3. Square root of 16 is 4. Minus x equals 3x. So I get 7 equals, if I add the x to the other side, 4x. Divide by 4. So 7 over 4 equals x. That's your answer. So if you have square root of 9, you don't write plus or minus 3. That's what I told you. Math teachers everywhere mess that up. Okay, next one. Real life problems. We usually use decimal approximations in these square root problems in real life. Like, I don't say, walk out 2 root 3 feet. Like, I'm not going to say that, right? I would probably say 3.4 feet, something like that. So it says the time t in seconds that it takes a pendulum to make a complete swing back and forth is given by this formula. So t equals 2 pi times the square root of L over g. So L is the length of the pendulum, and g is the acceleration due to gravity, which is this. So find the value for t for a 1.7 foot long pendulum. So that's the length. My length is 1.75. My gravity is 32. I'm finding t. So I'm just plugging everything in. So t equals 2 pi, the square root of L, which is 1.75, over g is 32. I would probably just put this all into my calculator all at once. Make sure you use the pi button. Do not use 3.14. Okay, so I'm going to have the square root of 175, or 1.75, divided by 32. And then I'm going to multiply by 2 pi. And I usually round to 3 decimal places. Okay, so I'm going to have 1.469. Okay, that is t. Go back through your problem and look for t. It says the time t in seconds. That is your unit. So it's 1.469 seconds. Okay. Number 2, so it says the relationship between the length and mass of the Pacific halibut can be approximated by the equation L equals 0.46 cube root of m. This is like the one random thing in the whole world that has a correlation between the length and mass. Like, think about it. If someone weighs, I don't know, 150 pounds, like a human, they're not necessarily a certain height, right? For this fish, though, it is pretty darn close. Isn't that weird? That it's not going to be like a really, really fat fish that's really short. Like, it doesn't work out that way. Okay, so it says the relationship between the length and mass is given by this equation. So I have L equals 0.46 cube root of m. M is the mass. You were told at the end to predict the length of a 25 kilogram Pacific halibut. So I'm going to plug that in for my m. So 0.46 cube root of 25. So if I was putting this all into my calculator at once, I would do 0.46 times 25 raised to the 1/3. So if you put it in just like that, it will do the cube root of 25, and then we'll multiply by 0.46. So I got 1.345, and this is L. So then go back through into your problem, and it says L is the length in meters, so it's meters. in the end. Units are important. All right, number 3. So it says the time it takes for a free-falling object to land on the ground can be found by the formula T equals the square root of 2d over g, where g is the acceleration due to gravity, but now it gives us a completely different number than we had up here. Do you guys see how these numbers are different? 32 feet per second squared, 9.8 meters per second squared. You see the different one? One is in feet, one is in meters. They're the same number. They're just different units. And d is the distance in meters. Find how long it takes for the ball to hit the ground when dropped from a building that is 30 meters high. So when you see 30 meters high, that is your distance. So d is 30. The gravity thing was g. So we have everything we need. So we have t equals the square root of 2 times 30 all over 9.8. And we put it all in together. Has anybody found it yet? 2 times 30 divided by 9.8. So I get 2.474. And again, go back into your problem and see what it says. So it says t is the time in seconds. So we have seconds in the end. It doesn't make sense that it would be hours. It takes 2.4 hours for a ball to drop 30 feet. So use the correct units. All right, any questions on that?